Now, water's not the only thing that does that. We also have something like this, rubbing alcohol. Here's 91% rubbing alcohol. If I put this on my hand, and assuming there's not a cut, and I was to blow across it, this alcohol is going to evaporate, meaning it's going to change state from a liquid to a vapor. That is a cooling effect. So if we put alcohol on like this, and if we move air across it, it is a cooling effect. It's changing state from a liquid form to a vapor form. It's actually absorbing heat. Now, if you're going to try these experiments, make sure you're away from any kind of a flame, make sure you don't have any cuts in it, and make sure you have adult supervision. So another thing we can look at, let's see what would happen if we used a mechanical device like this, and we turn this on, we move air across it, it'll speed evaporation up even faster. So let's try another little experiment. If we take alcohol, and we put alcohol in on this rag, and we're going to soak this rag in alcohol. This rag is now saturated. It's holding all of the possible moisture that it can hold. Now what I'm going to do is take this rag. Our thermometer here says 86. We're going to wrap this thermometer up in this rag right here. Let's do it a little looser. And we're already dropping in temperature. We're down to 83. And what we're going to do is put this fan across it. By putting this fan across it, we're speeding up the evaporation of our alcohol. Notice the alcohol always has a lid on it, because if you leave that lid off, it'll evaporate. So by moving the air across it, we're speeding up evaporation. If we put it on high speed, we can speed up evaporation even more. We're moving more air across this liquid, speeding up evaporation. So that means the alcohol is changing state from a liquid form to a vapor form. So it's absorbing heat. So if we look at our thermometer, our temperature thermometer is still at 83 degrees. The outside of this is starting to drop in temperature because of evaporation. Now, we know some very famous scientists all through history have worked and done experiments with evaporation, but one of the ones I remember is Benjamin Franklin. Benjamin Franklin, he's known for all kinds of experiments that he did, but one of the experiments he did was actually working with alcohol and rags. He was actually able to find out that evaporation absorbed heat. So by moving the air across this rag, it's causing evaporation. We can see the temperature of my thermometer is now down to 64.4 degrees and dropping. So there's a significant temperature change by having the fan move air across this rag. It's speeding up evaporation. Benjamin Franklin and a guy named Hadley were also doing experiments with alcohol. They actually used the thermometer, they put a rag on it and had a fan on it and had some evaporation. And I got to look at this to make sure I said it right. But Franklin and Hadley were able to reduce the temperature of a mercury thermometer 7 degrees Fahrenheit from 65-degree room. When ice formed on the bulb, Franklin remarked, now Franklin's a brilliant man. He could have said, hey, and we can make ice cream, we can have refrigeration, we could cool houses. But this is what Mr. Franklin said. From this experiment, one may see the possibility of freezing a man to death on a warm summer day. So no, not all the great things we can do with refrigeration. We could actually freeze a man to death on a warm summer day with this experiment. But in reality, we do use refrigeration in, say, morgues. We want to keep the body temperature lower so they can preserve it for many other reasons. And now we get into cryogenics to where we can actually freeze a body and different types of animation. That's beyond my expertise on it. But there's all kinds of things that we can do with this refrigeration. So the definition of a refrigerant is any substance that changes state from a liquid to a vapor and from a vapor back to a liquid, such as our evaporator coil, changing state from liquid to vapor. It's boiling inside of here. We're changing state from vapor back to a liquid. We're ejecting heat outside. So technically, water is a refrigerant, alcohol is a refrigerant, but there's many other types of refrigerant we're going to work with. Just like I can change the pressure and boiling point of water, we can also change the pressure and boiling point of alcohol. So let's see what alcohol does in that very same vacuum chamber. So here we have our vacuum chamber, and what I've done is I've filled the cup with alcohol. If you notice, the alcohol is clear, just like the water is clear. We're going to hold the camera on top. Hopefully the vibrations won't be too bad. We're going to power this pump up. We're starting out at 90.3 degrees Fahrenheit. We can see that the balloon is inflating, so there is a pressure difference. We're removing atmospheric pressure from this container. And if we see the the alcohol is violently boiling. It is boiling out of the container. I mean, it is violently boiling. So our temperature is dropping from 86, down to 89, 88, 87 now. So the temperature is dropping significantly fast as the refrigerant, in this case our alcohol, is changing state from a liquid to a vapor. It's actually spilling out of the container and it's boiling all underneath, but this is the refrigerant. So now we've gotten to our saturation temperature, so our violent boiling has stopped, but we are now still evaporating. So you see the temperature is still going to be dropping. So we're at 68.5 right now due to the pressure change. And if we look at the refrigerant or the alcohol that is spilled out, we can see that it is boiling inside of that container.